This is an instructional video for high-pressure die casting process, simulating without sleeve for AnyCasting software users. First, execute anyPRE to set the simulation condition. There are two ways to import STL files. Let's start with the first way. Click File and click Import to import the STL file. Import is a function that loads the saved modeling in STL format into anyPRE. Another way to import STL files is very simple. Simply just drag the STL file to anyPRE. Deactivate the mold entity to make sure that the imported STL file is loaded correctly. And set edge cavity, N-gate, channel, mold, overflow, and runner by using the set entity. When you simulate a real model of N-gate or runner, you can integrate it into runner. Casting only function is only used for flow analysis without mold, and is not used for general casting. Casting plus mold is used when simulating cavity and mold. When you click the Casting plus Mold button, you will see three different options. First of all, box is to create a virtual space. Please input the thickness of each direction. Second of all, shell thickness option will be enabled when you input shell thickness for investment casting. Lastly, mold entity is used when there is mold STL. Make cast from the cavity of mold is a function that recognizes the rest of the mold as cast when there is no cavity but mold data. In other words, if there is cast entity, even when you check this function, simulation will not be proceeded. In this case, since there is mold STL, please select mold entity. For those symmetrical cavities as shown in this example, symmetry must be kept when adjusting the domain. Click Set Domain to set the calculation area. You can adjust the calculation area by using the coordinates and the ratio, and as a result, only the part included in domain will generate mesh. There are three ways to generate mesh, which are build uniform mesh, build variable mesh, and auto mesh. First is build variable mesh. Press the spacebar to switch the mode to selection mode, then select Start and End. After entering dividing number, set the remaining part as auto block. Mesh will be generated in the orthogonal direction of the selected axis. Set the rest of the Y and Z axis. Mesh generation cannot be executed on the forwarded axis displayed on the screen when generating mesh. After setting X, Y, and Z axis, click OK button to generate mesh. Secondly, we'll look into uniform mesh. In the uniform mesh, there are a total number of cells dividing the simulation area into a fixed size mesh when the number of all cells is input. Also, there is number of cells along axis, which specifies the number of mesh in each axis direction, and size of unicell that specifies one cell size. Size of cell is a function that decides the mesh size of X, Y, and Z directions. The total number of mesh will be generated automatically by the program, based on the values entered by the user. The last one is AutoMesh. Click Automeshing. For X, Y, and Z, after setting the minimum and the maximum size of AutoMesh, minimum and maximum size as the reference value of the generated mesh size. Let's start with task design. After selecting the process, please select the range of simulation. In the material setting, double-click the entity to select the material. Multiple selections can also be made by pressing the Ctrl or Shift key. In initial condition, enter the initial temperature of each entity. The initial temperature here states the temperature before the simulation starts. Heat transfer coefficient value is input automatically. But please make sure if the value is right or not. The heat transfer coefficient unit of this video is calorie. Please set the pour temperature in gate condition. Press the spacebar to switch to selection mode and select the gate. The color of selected gate will be changed to yellow. When setting the gate condition, please switch to mesh mode. To set gravity force, please click Enable and set the gravity direction. The gravity direction is based on the axis displayed on the screen. Gas and melt surface is a function that predicts the amount and the position of the generated gas when melt is poured into the cavity. Oxide slide inclusion model is a function to set oxide occur conditions and to predict oxide dispersion in cavity. After activating it, click the icon next to variable temperature to see the value of the automatic input. The input value should be 0 at solidification temperature of melt material and 1 at pouring temperature. Particle tracing is a function to track the movement path by expressing the melt as particles coming through a gate. Click to enable Start/End control. For particle source value, in the case of high-pressure die casting, it is common to set it to bi-filling rate because the pouring time is short. Shrinkage model is a model for predicting solidification shrinkage. For high-pressure die casting process, gravity shrinkage is not considered. Shot sleeve model sets the high/low speed length of sleeve, as well as speed and time of the sleeve by entering the conditions of die casting equipment. In the sleeve tab, set the sleeve length, diameter, and biscuit thickness. Sleeve length value should include the thickness of biscuit. Melt charging is a setting of the melt in the sleeve, which is automatic setting and will be passed after confirmation. In Shot tab, set the speed and length at low/high speed. If you don't know the high speed, input the low speed section in the speed and press reference, and then input the in-gate area to be calculated automatically. Also, instead of using the optimized data, if you change the in-gate area and in-gate speed to the speed you want and press apply, then the program will automatically calculate the high speed depending on its area. Activate both mold erosion, that predicts mold erosion area, and gate flow tracking, which shows the flow of melt from in-gate and gate. There are two ways to install a sensor. First is by using a mouse, and the other is by inputting coordinates. Sensor allows you to view speed, pressure, temperature, and etc. in a specific part out of simulation area. Channel is for setting the cooling channel. If you set channel in the entity setting, the entity will appear in the window. Then select Entity and click Properties to set the time/flux setting. The temperature of channel will be maintained at the temperature set by user, instead of the way the cooling water flows into the channel. And it will be set based on the average value of inlet/outlet temperature. After setting in/out condition, click Save, then presetting process will all be done. In general, for end condition, please select 100% solidification. However, this can vary depending on the test design setting. The information shows in progress result are temperature, oxide, velocity, flow tracking, and these can be checked only according to the output interval set in output condition. When setting is done on anyPRE and the file is saved, 8 files will be created in the folder. If the extension is GSCX, it is the file that contains some contents from anyPRE. MIF6X is virtual mesh information on real flow. Therefore, if you delete it, real flow will not be applied. MSHX includes physical mesh information. PRPX is a solver execution file. PXM, XML, TXT, and VPX are the files that store information about simulation settings. X after the file name means 64-bit. Thank you for watching.